Tri-state buffers have several other important applications as well. The first application is you can design multiplexers using tri-state buffers. So the problem statement is design a 2-to-1 mux using tri-state buffers. So let's look at it. Now remember, a mux will look something as follows: 0, 1. You have inputs A, B, and enable, and then F. We typically refer to this as a select, but you can also put it as enable. It's one and the same. Okay. Now you know that when enable is 0, then F is equals to A, and when enable equals to 1, F is equals to B. So how can you design this logic using tri-state buffers? For this, we have to use one active low buffer and one active high tri-state buffer. And the logic is as follows. So you have A, B, so A has a buffer, B has a buffer, right? So either A has to come out or B has to come out. And the only way that you can do that is have an enable signal. So remember, when enable is 0, F should output A. The only way that you can output A when enable is 0 is if you use a active low tri-state buffer. And when enable is 1, F should be B. Therefore, the only way that you can do it is using a active high tri-state buffer. And this is the mux design. In fact, muxes in real world are designed using tri-state buffers. Another important application is using tri-state buffers to create a transceiver. Transceiver is a device or a circuit that is capable of sending data from the input to the output and also from the output to the input. So data can go from the input port to the output port, and it can also flow from the output port to the input port. And transceivers are very much used in communication networks. So how do you build a transceiver using tri-state buffers? Again, the logic is the same. So let's say I have one port here. This port can be input or output. This is one buffer. It's not a tri-state buffer yet. It's just one buffer. This is another buffer. I have an enable signal. So this tri-state buffer is an active low tri-state buffer, and this buffer is an active high tri-state buffer. Now let us see how the circuit behaves as a transceiver. So take the first case where enable equals to 0, which means this buffer is on and this buffer is off, which means it acts as an open circuit, right? It's in high impedance state. Therefore, all this circuit will be off, and the only way for the data to flow is from this port all the way to the output here. So in this case, this one acts as the input port and this one acts as the output port. Now let's take the reverse case. If enable equals to 1, which means this buffer or this tri-state buffer acts as an open circuit or in a high impedance state, and the buffer on top is on, right? Since this is high impedance, all this is open circuit, so nothing is going to go from here. And since this is on, it acts as a short circuit, therefore data is going to flow all the way from here to here. Therefore, in this case, this one acts as the input and this one acts as the output. Now, depending upon enable being 0 or 1, the inputs and the output ports are going to change. And this is the basic operation of a transceiver. This is another important application of tri-state buffers.